Alright, let us now come to transistor testing and troubleshooting for a bipolar junction transistors. Okay. You can notice, class, that the bipolar junction transistors are of different structures. That means they are of different shapes and sizes, bigger and smaller transistors. This type of transistor is of diagonal shape metal plate. We have a rectangular shape. We have a smaller shape, smaller transistors. Okay. NPN and PNP are of the same structures, but different type. Okay. So our main purpose here is to locate the three electrodes of transistors. You can notice that these transistors are provided with three external terminals, the base, collector, and emitter. But remember that there is no single arrangement for this transistor electrodes. Base sometimes found in this side here, or sometimes they are located at the center, or it is sometimes located here. So it is very important for us to locate for the three electrodes. Okay? Now, the first thing to do when you are finding the three electrodes of this transistor is to locate the type of the transistor. Whether this transistor is NPN type or PNP type. And of course, also, when you locate the type of this transistor, you can also locate the base of this transistor. Okay? So it goes like this. Just imagine that a transistor NPN is equipped with two diodes connected in inverse connection we have here. NPN type, wherein base is positive, emitter and collector are negatives. Meaning, these negatives here actually are the two cathodes of the two diodes. Whereas, the two anodes are connected together, and that is now the base. Anode positive, cathode negative. Meaning to say, the base here are actually the two anodes. Are actually the two anodes, of course, the two anodes here, the base. Whereas the emitter and collector are the cathodes. Okay? Meaning to say, we have to use the ohmmeter. For sure, use times 10 ohms. As what I have said before, that to make your semiconductor devices safety, beware from using times 1 because it offers higher amount of current compared to times 10. No? Especially when you are testing low power rated transistors such as this one. Low power rated because the power ratings here for this type of transistors, the maximum is only 400 milliwatts, below 1 watt. So they are susceptible to higher amount of current, of course. Unlike these powerful transistors over here, these transistors are used for large signal amplifiers, whereas the low power rated transistors like this are for small signal amplifiers. So anyway, these high power rated transistors can control the higher amount of current here, although you are using the smaller amount of ohmmeterings. Okay? At first, we have here, let us look for the type of transistor. Okay, we have here. This is actually NPN type probably. Okay? NPN type. Okay? So, if your two test rods are connected to emitter and collector, we have here, emitter and collector, there are no deflections for emitter collector because this is actually the base. Meaning, because the two diodes are connected in inverse connection, they are not connected in series. So, infinity, no deflection of the pointer. So, meaning to say, the center here is the base. Sir. Okay. So, just like that. Then, we have here the
base, probably this is emitter or collector. Then, retain this black test rod. Remember, the black test rod is positive, ha? And red test rod is negative for the emitter. Then, retain the black test rod to the center. So, deflect, then deflect. Here, deflect, deflect. Meaning to say, this is base. Base is positive. Huh? The black test rod for the emitter is positive actually. Base, over here, deflect, deflect. Meaning to say, base over here, deflect, deflect. Because anode is always positive. So this is the base. Base. Because over here, if you transfer the black test rod over here, no deflection. So go back to the deflecting pointer over here. Then move this positive or this red test rod to the other terminal. Deflect, deflect. Meaning to say this is base. And base is positive. Because this is positive for the emitter. Base is positive, negative, negative. Negative, negative. So, base is positive. So that this is NPN type. No, NPN type. Because this symbol here corresponds to the symbol of the NPN type. So, again, positive black test rod for the base, negative over here, negative over here. So this is the base and the base is positive. So we need to say NPN type because the center there is positive, center is base. Okay? So in the next move is to look for the emitter and collector. Remember that the base is positive. When you look for the emitter and collector, you have to change the range selector switch or the ohmmeter range to times 10K. Always times 10K. You cannot use times 100K nor times 1K. The ohmmeter range should be set to times 100K. Okay? When you look for the base and the type, set it to times 10 ohms. But when you look for the emitter and collector, set it to times 100K. Okay? A while ago, you knew already that base is positive and it is NPN type, di ba? Okay. Now, this is the base which is positive. Okay. You have to reverse now the polarity. The base which is positive now is connected to the negative side, red. There is deflection. Whereas here, walang deflection. No deflection over here. But here there is deflection. So this is now the emitter. The deflecting pointer is the emitter. Because you knew already that this is base. So this is emitter. Because it deflects when you are using times 10K. Because when it is times 10 ohms, deflect for base emitter over here. But when you reverse, you make the base negative or red test rod, walang deflection. But when you set it to times 10K, base which is positive now is reversed to negative. No deflection for base collector. But with base emitter, there is always deflection for the base emitter. Meaning to say, this is the emitter, this is the base, and this is now the collector. And it is NPN type because base is positive. Now, for the PNP type, let us look for the PNP type. The base is at the center. No? It goes like this type of transistor. Base, collector, emitter. But, let us try another transistor. Use times 10 ohms. Deflect. Deflect. Okay. This is PNP type. PNP type. Why? Because when it goes like this, okay, deflect, deflect. No deflection, no deflection. So look for the deflecting pointer. Deflect. When you move this retest rod to the other terminal, walang deflection. So go back to the deflecting pointer. Go back to the deflecting pointer. Deflect. 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 Here. Okay. Deflect. 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 Meaning to say, the center terminal is base. And it is negative. So PNP type. PNP. Because it goes like this. Oh. Deflect. Deflect. Remember that this is positive for the emitter. And it is connected to the anode of the emitter and anode of the collector. The two cathodes are actually connected together that serve as a base. Okay? Okay? You are using times 10 ohms again. Deflect, deflect. Because when it is deflecting here, then you transfer the red test rod here, no deflection. So go back to the deflecting pointer, then move the black test rod to the next terminal. So deflect, deflect. So this is base. And this is negative, so PNP type transistor. Then, when you look for the collector and emitter electrodes, set it to times 10 key. Okay? Then reverse. Because PNP, red base, now swap it or change it to negative or to positive. Deflect, walang deflection. Deflect. So this is the emitter. And this is the collector with no deflection. With deflection at emitter, base emitter. Using times 10K. When you are looking for emitter and collector. Okay? So, a while ago, the base is at the center. And the emitter is over here. And collector is over here. But, when the transistor is this number, 9013, the base is over here, and the collector is over here, and the emitter is over here. Okay? So, it doesn't mean to say that the arrangement of the external terminals for the three electrodes is of one arrangement. They are of different arrangement. That is why it is very important for us to look for the electrodes, the external terminals of the electrodes using times 10 ohmmeter. No? Then, another type of transistors like this. You notice that there are only two terminals. Actually, it has three terminals. This is a metal shape or diagonal shape metal plate. This is the metal plate, diagonal form. So, actually, the metal case is already the collector. And the emitter and base is over here. So, look for the base and emitter. Anyway, this is now the collector. This is a large signal amplifier. Actually, the power rating here, because this is MG2955, the power rating here is 115 watts. But whereas these transistors are below 1 watt, and that the power ratings of these transistors, for example, for the AC1815, the power rating is only 400 milliwatts. For the 1402 transistor, the power rating there is only 250 to 350 milliwatts. No? Okay? This is a large signal amplifier transistors. Look for the base. Okay? We have here. Transfer the red test rod to this terminal here or to this metal case. No deflection. So go back to the deflecting pointer. Use again times 10 ohms. Okay? Deflect. 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 Meaning to say this is the base. And this should be the emitter because this metal case is already the collector. And one important thing for measuring the transistor is to look also or to know also if the transistor is defective or not. No? Okay. For this type of transistor, the metal case here that serves as a heatsink is already the collector. No, this is already the collector. So it is actually connected to this terminal, which is collector. Okay, we have here. Okay. Okay. Connected. Meaning to say this metal case is already connected to this terminal, external terminal of collector. Okay. Now, to prove that this transistor is still good, look for the base and emitter. Look for the base and emitter. Okay. Transfer the black test rod to the center. No deflection. Go back to the deflecting pointer. Deflect. Transfer the red test rod to this terminal. So, deflect, deflect. So, this is the base. And the type of this transistor is NPN type because base is positive. Oh. Okay. So, this is base. And you know already that this is collector because it is connected to the metal case. But to prove, so let us change it to times 10K. So a while ago, we knew that base is positive. Okay, let us reverse. Reverse. So, base to this terminal center, no deflection. Back. No deflection. Here, there is deflection. So this is now the emitter. Reverse polarity, reverse polarity. Because negative base is connected to the base positive here. Because NPN is connected to the negative of the emitter. Deflect. No deflection. So the deflecting pointer is now the emitter. This is the emitter and this is the base. Okay, it goes like that, class. Now, those are the normal measurement of the bipolar junction resistors for the NPN and the PNP type. Let us now proceed to the troubleshooting. How do we know that the transistor is defective? So, there are actually three types of troubles or symptoms of these transistors. We have the shorted transistor, we have the open transistor, and we have the leaky transistor. Okay, we have here. This transistor is a power transistor because it is a large signal amplifier transistor. Based from the number, specification number here, 2SA 12116. 1216. This is PNP type transistor and the power rating actually is 200 watts. This is a very powerful transistor. Okay? Let us prove. Use times 10 ohms. Times 10 ohms. And for sure, set it to 0 ohm by means of this 0 ohm adjuster. No? When you are using the ohmmeter ranges, especially when you are changing the ohmmeter ranges, you have to set first the 0 ohm adjuster to 0 ohm scale. 0 ohm, 0 ohm, shorted. So, shorted. So, this is damaged already. You can no longer use this one. In a certain amplifier, the symptom of your power amplifier usually, there is a hum sound, very hot. Transistors is very hot. No, this transistor is very hot. Meaning to say, shorted. And sometimes the fuse of that amplifier will blow. Puputok yung fuse. Then it is totally dead. No? When you replace the fuse with functional one, again, it will blow. Meaning to say, there's something shorted at the output. And this is the output power amplifier actually. No? So, shorted. How about this transistor? This one. Using again times 10 ohms. Okay. 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 Deflect. Deflect. Change. No deflection. There is deflection here. Over here. So, no deflection, with deflection. So this is the base actually, and this is the collector and emitter. Because this is to AC 1815, base, collector, and emitter. So base collector is good, base collector junction is good, but base emitter is damaged. Open. Base emitter junction is open. So we cannot use this one anymore. This is defective transistor. Then, how about this shorted, open, leaky? Let us come to the leaky. If there is available leaky transistor here, how about this one? If this is leaky. Okay. Okay. Good. 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 How about reverse? Good. Good transistor. How about this one? Okay, deflect. Deflect. Leaky. Base, emitter, base, collector. Good. But, collector, emitter, there is deflection. Even you are using times 10 ohm range. There is deflection. Meaning this is leaky. Emitter, collector, leaky. Okay? Emitter, collector, leaky. Okay? There should be no deflection here when you are using times 10 ohms. But here, there is deflection already. So there is leaky. Leakage, emitter, collector junction. So at first, so that you can easily determine whether the transistor is defective or not, you have to be familiarized yet with the normal measurement of this transistor. Looking for the three electrodes of this transistor, the emitter, collector, and base. But remember that the external terminal of these three electrodes are of different arrangement. It is not always in single arrangement na base, collector, emitter. Sometimes base is located at the center, sometimes located at the right portion or the left portion. So it is very important for us to use times 10 ohm range for looking the three electrodes. Internally, the three electrodes are arranged like this: emitter, base, and collector. But the external terminal of that three electrodes inside the plastic package of that transistor is different arrangement. Okay? Those are all about bipolar junction transistors, NPN and PNP type. And now let us come to the junction Philippine transistor. Okay, remember that there are two channels of this junction Philippine transistors. These are the junction Philippine transistor or JFET N channel and the JFET P channel. Okay, we have available junction Philippine transistors here. I think this is N channel type. Again, use times 10 ohms. Use times 10 ohms, Look for the gate. The gate corresponds to base of the BJT or bipolar junction transistor. Drain corresponds to collector. And source corresponds to emitter. Okay. Okay. Deflect. Higher deflection here. When you reverse here, deflect. The center is black test rod. Transfer the red to the other terminal here. Okay. This is now the gate. And the gate is positive. The gate is positive. No? Okay? Okay. The gate is positive. When you reverse, no deflection. So, walang deflection. There is deflection. There is deflection here. Just like bipolar junction transistor. So this is now the gate. And the gate is positive. So, if the gate is positive, the drain and the source are negative. Remember that the connection or the passage of the current is from the source and the drain. N channel. This is N channel junction Philippine transistor because the gate is positive. The gate is positive. The gate is positive. So this is down the gate. The gate is positive, meaning to say N channel, because the emitter of the source and the drain are negatives man. So the drain and the source region is actually the channel. That is the positive current. So N channel type. And where is the drain and the source? There is no search theory for finding the drain and the source. So you can refer to the internet website if you have transistor manual for the GFET. There is a data sheet there. Data sheet for the bipolar junction transistor. So the data sheet will tell you where is the drain and the source. But anyway, there is no risk when it is inverted, when the drain and the source are inverted. Because most electronic experts say that drain and source are reversible or they can be interchanged. Most electronic experts say, but some, it couldn't be. There's a little difference for that. But for sure, refer to the GFET manual or junction Philippine transistor manual, or you may search it to the Google or internet website. Look for example, base the specification number, because at the surface of this transistor there is always a specification number. The specification number will tell you whether it is GFET, whether it is bipolar junction transistor. Look for that number to the Google. The Google will tell you everything about the behavior, the characteristic of that transistor, because there is a data sheet there. No? Remember, there are different types of transistors. We have also unijunction transistor. We have also MOSFET. We have also quadrac, diac. Actually, triac, diac, quadrac are not transistors. They are thyristors, fast-acting switch, which will be discussed later on. They are of the same shape and sizes, the same structure with bipolar junction transistor. How do we know that this is ECR? By means of the specification rating, no? Printed on the surface of this ECR or of this triac. Remember that there is the same shape, the same structure with these transistors here. Remember that one? Okay, the same shape. What differs then actually is the measurement. Different measurement, different electrodes. The electrodes of this triac, for example, is gate, MT1, MT2. For the ECR, gate, anode, cathode. So, it is very important for us to refer also to look for the specification number of that transistor. Then look or refer to that to the internet website. Google, then type the specification rating for that. So that you would know whether it is triac, diac, quadrac, or whether it is a bipolar junction transistor, or whether it is a GFET transistor, or whether it is a MOSFET. No? Okay, class. If you have queries and suggestions, please do not hesitate to send me, because good suggestions and queries deserve good responses. Thank you and goodbye, class.